Hey everyone, I'm Prof. Andy Gunawardena, and I'm super excited to take you on this journey through SQL database implementation using Jupyter. This is going to be an interactive experience where I'll guide you step by step. Don't forget to check out my website at andyguna.com for even more great resources. All right, let's dive in and make some data magic happen. We'll kick things off by accessing a Jupyter platform like Codabench.us or Google Colab. Then we'll dive into essential database operations like clearing out old databases, creating new ones, adding tables, verifying those tables, inserting records, loading data from CSV files, and double-checking that every CSV record is successfully added. By the end, you'll have a basic foundational knowledge for working with SQL databases right away in Jupyter. Let's make this hands-on and fun. Before removing an old database, let's go over some essential steps. First, double-check its usage. Ensure it's truly outdated by verifying that no applications, users, or processes are relying on it. You definitely don't want to disrupt anything important. Next, identify any dependencies that could affect other systems. And remember, always back up old databases, even if it seems unused. A secure backup means you're covered for any future needs. Before diving into creating a new database, let's set a solid foundation. Start by defining the purpose and requirements. What data will it store? How will it be used? Map out the data structures and relationships you'll need. Think about scalability too. Plan for future growth so your database can expand with you. Identify who will be using it, along with their roles and permissions for secure access. And don't forget to check if test.db is saved on your local system after creation. If you want to delete this database, you can just delete the file, but in real applications, you must take great care. When adding new tables to a database, let's go through some key steps to make it smooth and effective. First, clarify the purpose and data needs. What's this table for and what info will it hold? Then get into planning the table schema. Choose clear column names, set data types, add a primary key for unique IDs, and add constraints like not null or unique to keep data solid and reliable. Think about how it'll link up with existing tables and any special constraints. With these steps, your new table will be rock solid and ready to support your data science goals. Now pause the video and implement the code so far. To keep your database running smoothly and accurately, let's make sure we're verifying the schema when adding new tables. This means double-checking that each column, data type, and constraint matches your design plan. Plus, it's key to validate relationships with other tables like foreign keys and constraints to maintain database integrity. In an upcoming video, we'll go over preventing data integrity issues in more detail, and remember, using Jupyter code can make it super easy to check if your tables are successfully added. Now let's enjoy adding a new record to a database. But first, make sure you understand the table schema. Double-check those column names, data types, and required fields to keep data integrity strong. Keep an eye out for not null constraints to avoid errors along the way. Default values can be a big help too. They kick in automatically when no value is specified. And for all you Python enthusiasts, SQL Alchemy is a fantastic library for database interactions, giving you both high-level ORM and low-level SQL power. Let's get those records in place with confidence. Checking database content is super important for keeping data integrity solid and your application running smoothly. It helps optimize performance and stops duplicate data from sneaking in. By verifying what's already in there, you'll avoid inserting duplicate records and keep your database nice and clean. Tables often have unique constraints for fields like usernames or email addresses, so checking content is a great way to prevent any constraint violations. Use Jupyter code to print all records or a specific amount like 20 to get a quick overview. Loading data from a CSV file into a database is a game changer for efficient data management and analysis. Why is it so important? First, it saves tons of time since CSV files are super common for data sharing. Second, when dealing with large data sets, automated loading is essential for quick database population. This skill is a must-have for working with big data. Use Jupyter code to easily load CSV data into a compatible database table. Mastering these skills will streamline your data workflow and take your analysis skills to the next level. Checking if all records from a CSV file have made it into the database is essential for data completeness, accuracy, and reliability. Ensuring data completeness means no missing data, keeping everything consistent and reliable. By verifying all records, you can catch issues like network interruptions or format mismatches that might disrupt the data load. This is also your chance to fix any integrity errors like constraint violations or missing values in required fields. Use Jupyter Code to double-check that everything is loaded correctly for a thorough review. This process keeps your data solid and enhances your database quality. Mastering key database operations is essential for effective management. Here's a quick rundown. Removing old databases. Use specific commands or delete the file. Out with the old. Creating a new database. Define its purpose, pick the right DBMs, and configure your settings for success. Adding tables, design the schema, set keys, and build relationships to keep data structured. Verifying table creation, double-check accuracy to ensure everything's set up right. Adding records, keep data integrity strong by managing constraints for consistency. Regularly reviewing content, maintain accuracy with routine checks. Loading data from CSV files, quickly populate your database while ensuring completeness and reliability. These foundational skills help you create well-organized, functional databases that align with data integrity standards. Until next time, enjoy managing data with databases and SQL. Bye now.